How you doing, guys? This is Joe with LVV HVAC. It's September 10th. We have a Lennox gas-fired furnace with a AC coil onto it. It's the end of the summer, and we got no power going to the board. Okay, even when you push the safety door switch, no power at all. Now I'll show you. We've got power coming in right here to the transformer, but no power coming out. So that leads us to the transformer, which we did change last year. Okay, so we got to see why this popped again. Could it be a bad transformer? Sure, but maybe it's a sticky contact, on the contactor downstairs, so we'll see what's drawing this up. Now, in order to see how many amps a transformer could have, you've got that 40 VA right there, right? 40 VA by the secondary, which is 24 volts right there. So if we divide the 24 into 40, that'll give you how many amps this transformer can handle or hold. Okay, so I'm gonna put a new one. Okay, which is stronger. It's a 50 VA. All right, so this one here. Okay, if you go 24 volts by 50 VA. Okay, so let's see here. Can we find the 20? Where's the second? Right there is 24 volts. Let's zoom in there. All right, by the where's the VA? Where's that VA? Right there. No. Where are you, VA? Come on, stop hiding from me. 120, blah blah blah. Right underneath it. Okay, there you go. All right, so 24 volts divided into 50 is going to give you 2. So this transformer should be able to handle 2 amps. And if it does go over 2 amps, you got the built-in circuit breaker. It's just going to pop for you. Okay, it's like a popper. All right, so you don't kill the transformer. I really should have put maybe like a 2 amp fuse or 1.5 amp fuse on this. So if it did get too much, it would pop it. Instead of popping the transformer, it would pop the 25-cent fuse. But I'm just gonna put this back. All right, but then I will check the contact to make sure it's not sticky. Make sure I'm gonna also do an amp reading and make sure there's very low amps, not going to exceed what we're going to put in for it. All right, so I'll change this out. And before I do that, I'll put the power on and I'll show you how we have power here and no power here. All right, give me a minute. All right, guys, so I forgot my little door switch thing all the way down there, so I'm going to have to improvise. All right, you see here? We got 122. All right, coming in. So we got power. And now, let me undo these wire nuts and I'll show you we got nothing coming out of the second. All right, guys, so now we're here. Door switch is closed. My probes are on the wires, secondary, and nothing. See that? So I'm going to change out this transformer, and that should make this unit run and give us and not give us a problem. We'll be able to get these guys back up what they see. All right, we'll get right back. All right, guys. So we have the new transformer tied in. We got the black and the white right here connected. All right, the white is on this transformer. The black, even though it probably doesn't make too much of a difference. The black is the common, so I hooked that up to the neutrals here. Okay, and the white is the 120, so I hooked that up to the 120 that goes to the board. Okay, and then you have the blue and the yellow, which is the 24 volts. All right, so we're gonna fire this up and make sure it works properly. Okay, and I had to go back to my bag, so I got my my little switch closer, which is awesome. All right, so we got power. AC is on outside because you can hear the whistling of the refrigerant coming through. Lower motor is on, and we seem good. All right, now quickly what I want to do is I want to take an amp reading. .3 amps on blue, 0.3 amps on yellow. Sorry guys, hold on. Sorry about that. And on white there's 0.7. On black 0.06. So the majority of the amperage is on the secondary, which is 0.3, which should be 100% fine. And we're all good. I'm going to put the cover back on here so it's sucking air properly. I'll show you guys when it's all buttoned up. Alright guys, so it's all buttoned up. Okay, here's the whole system. Right here. That's the return. That's the supply. And you know what? Just to give you guys a little bit of a sidebar. Okay, this is the return, right? So that's sucking air in, going through the coil, going through the blower assembly, through the heating assembly, and goes to the coil. Whenever you have a coil on the positive side pressure, okay, you don't need a trap, because that air is going to blow that water out of that coil, okay? Sometimes they say a trap is not good to have, but whatever. That could just be a regular straight pipe. I don't know if he did that because his angle iron, you know, his support is right there, but I don't know. He could have done it differently. Normally when the return and the coil are right next to each other, what happens is if the blower assembly is reversed, you have a negative pressure in that coil because it's sucking from the return here, and then you have the coil here, and then the blower's here. So that blower being here is sucking air this way, which that's why you need a trap, okay? Because then it will suck the air in through that hole, through the 3/4 PVC, and then it won't let the water drain properly. But because the air is going from here through here into the coil, it'll push its way out of here. Okay, so if you ever see a positive coil, it's called positive coil. If that coil was here, right next to the before the blower, all right, that would be a negative coil. Negative coils need a trap. Positive coils do not need a trap. Okay, so I'll let the customer know that they really don't need a trap here, and that gets clogged up a lot. I don't really see it too much with the straight pipe. You know, the clog might be on the outside or something like that, but you know, just for the technician's knowledge, positive coil. All right, so if the coil is after the blower, all right, then no trap. If the coil is before the blower, right next to the return duct, and that's sucking air to go through the coil, and then you have the blower afterwards, that would be negative pressure, and you do need that trap. All right, guys. So we got less than 1 amp on this machine over here for the load. It should not pop this transformer. See you guys next time. All right. Any questions? Any comments? You can write them below. I'll get back to you.